Welcome back, Physics 30. So today we're going to look at V1.1 and 1.2. So looking at vectors and scalars, looking at what they are, and then looking at adding vectors using a graphical method. So what we'll be doing is distinguishing between vectors and scalar quantities, representing the magnitude and direction of a vector quantity using a protractor and ruler. And if two vectors form a right triangle, we'll be able to add them together using some trig and Pythagorean theorem, and then add two or more vectors graphically to determine the resultant using an appropriate scale diagram. So a few things to note. So defined here, a vector is something that has a magnitude and a direction. And by magnitude, what we really mean is it has a size, so it has a bigness, and also a direction, and we'll look at some of the direction conventions with that. So some vector quantities include displacement, velocity, such as shown over here, force, and momentum. Now, to distinguish a vector from a scalar just only has a magnitude only. So it has a size, but no direction. So some vector or some scalar quantity examples include mass, time, and temperature. And of course, what we do here to demonstrate a vector in terms of a magnitude and a direction is we draw an arrow. So an arrow is used to represent a vector quantity, and we usually draw it to the length that represents how big it is, and also the direction that the arrow is pointing. That demonstrates the direction of the vector. And if we look over here, so the direction convention that we're going to be using, of course, it looks something like this. So north, east, south, west. And everything will be in relation to that. So if we look over here, we'll draw a few examples here. So draw a scale diagram to represent each vector and state the scale used. Now, the scale you want to make on a piece of paper is roughly, you want to draw vectors that are around 5 centimeters long, 6 centimeters. Those are usually reasonable lengths to draw on your paper. So we'll try to make it so that our vectors maintain about that length. So if I was drawing something that represents 4.5 kilometers, obviously I wouldn't draw it 4.5 kilometers, because on my paper, I'm going to likely be dealing with centimeters. So scale will be in terms of 1 centimeter equals so many kilometers in this case, or meters over here. So a reasonable one here would be, well, I could draw something that's 4.5 centimeters. So for this first one, I could easily make 1 centimeter equals 1 kilometer. Okay, so that's what I'm going to do. And of course, going west, of course, that's going to be going this way, as we can see over here. So I wouldn't want to start over here because I'll go running off the paper. I may want to start over here. So that's something to be aware of when you're looking at this. Make it so that you don't go off the paper. So over here, 4.5 centimeters. So I'll line this up to 4.5. So I'm going to go as far as here. That's going to represent 4.5. So draw it like that, and be careful. Make it exact here. Don't go over. And make sure the arrowhead also coincides with the end of that arrow. Okay? And then I can call that V1. And if you noticed here, there's a little half arrow. That half arrow indicates that the variable is a vector quantity. So we usually draw that with the half arrow. All right, let's look at another example. So, and again here, you can see if I measured this, it's 4.5 centimeters. 4.5 centimeters equals 1 kilometer, and it's pointing west. So the square, we have our directions enclosed in the square bracket. If I look at this one, it says east 25 south. Now how we interpret that is that we start here. So that's going to be 0 degrees on protractor. So you're going to line up your protractor so you're 0 degrees is going to be at this first direction, and then move this direction. Okay, so we'll see how that looks. So starting east, so if we imagine this pen is pointing east, then from there we're going to move in the south. So south would be, of course, down on your page, so it'd be like turning this and going south. So our vector is going to be pointing in this direction, so it likely makes sense to start drawing it over here somewhere. Okay, so what you could do here, now since it's at an angle, it's not a left, right, or up or down like this one, you likely have to start by drawing a little Cartesian coordinate system right here. So kind of drawing an X and Y axis, and if I line this dotted line up with one of the lines on the ruler, I'll automatically have a perpendicular line. So if I can accomplish that, then I automatically get the right thing I need. All right, so if I put it like this, so I need to start here. My 0 on my protractor has to be pointing east. So start my middle here, pointing east. And this would be fine if I was moving north, but I'm moving south. So if you notice on a protractor, there's two scales. I could orientate it this way, and my 0 is here. Oh, and now I end up moving south. Now I can move south. So I move south by 25. So 5, 10, 15, 20, 25 is about right there. So I'll make a little tick mark. Now one thing we forgot to do here, of course, was talk about the scale that we're using. So 1 centimeter on my paper. Now obviously I'm not going to make this 25 centimeters, so 1 equals 1 doesn't work. 25 is divisible by 5. So I can make 1 equals 5. That way if I wanted to draw something that's 25 meters, you can see that that's 5 times bigger, so I would make it 5 times bigger, so that would be 5 centimeters. So that's kind of how we can work that scale. If 1 equals 5, then 5 equals 25. Times by 5 times by 5. So that little dot I made over here, I'm going to just draw this 5 centimeters, because that's what my scale is. So start off at 0 here. And let's see, I wanted to go as far as 5, which is right here. So careful, right at 5 there is where I wanted to make that tip of the arrow. Right there. And of course this angle here is my 25-degree angle. So if you do have an angle, you should likely show it where it is. And that of course is vector V2. So that's how you do it. So again, look at when it's not straight north, south, east, or west. When it's in this form, you have to place the first direction is going to be your 0 on your protractor. So you have to figure out, am I using this scale or this scale? Because from there you have to move in a particular direction. And evidently what we're doing here is where our vector will likely be in quadrant 1, quadrant 2, or quadrant 3, or quadrant 4 from math class. This one here would be in quadrant 4. So of course we're going to be talking about east and south. East and south. So sometimes it would be south so many degrees east, other times it could be east so many degrees south. Then of course with a vector like this, it lies directly on the north, south, east, or west axis. All right, on the next page there's 2 more examples. I'm going to have you go through that and then look at the next video to see how you did. All right, so try those 2 examples, then look at the next video. All right, we'll see you again.